begin. Currently I am working on a 3D printed robotic arm that needs several servos, and to control them I needed a controller with at least 6 channels. While browsing Amazon, I found one with great reviews, but the price blew my mind. So I thought, challenge accepted, let's try to make it under $5 using a Nano and some spare parts I had lying around. But before risking the only Nano that I have, I decided to build the circuit in Tinkercad. I'm using an Uno because Nano isn't available on Tinkercad. That's why there may be some connection differences between this simulation and the actual circuit. So the first task was to determine the number of inputs and outputs and assign them to the pins. We have only one type of output device here, the servo motor. There are 6 of them, so we need 6 digital output pins, and these are the pins. For the input devices, there are 6 push buttons and 6 potentiometers. Since the potentiometer sends analog values to the Arduino to control the servo position, we need analog pins. Thus, pins A1 to A6 are connected to the wiper terminals of the potentiometers. On the other hand, a push button is just a 0 or 1 input, requiring a digital input pin. The pins I am using for these are 2, 4, 7, 8, 12 and A0. Now a very important point here. The last button is connected to pin 13 on the Uno in Tinkercad, but in the actual circuit on the Nano, it will be connected to pin A0. Why? Because there's an issue with Nano's pin 13 when you use it as digital input with input pull-up. And I learned this the very hard way. But more about that in a separate video. So after some trial and error, I got the circuit working. And check it out. These 6 servo motors are each controlled by their own potentiometers and buttons. I'll dive into the details later, but if you're eager to try this circuit right now, you can just copy my design from the description in Tinkercad and start right away. Next, it was time to build the physical circuit and test the code. And what better way than using a breadboard? I connected 2 servos to the Arduino and uploaded the program. So there are 2 modes to control the motors. First is manual mode using the potentiometer, where the servo position changes based on its rotation. Second is auto mode, in which the servo resets to its original position, 0 degrees by the way, when the push button is pressed, making the potentiometer inactive. Press the button again and manual mode is back in action. You can find the program link in the description, and if you need a code explanation, don't worry, I have left comments at every line. Confident with the program and circuit, it was time to make it compact. For this, I designed the PCB in Circuit Maker, and after finalizing the design, I ordered the PCBs from a local manufacturer. In just 5 days, the parcel arrived at my doorstep. The PCB quality is decent, the silk screen, solder mask, everything. I then place the component on the PCB and solder them one by one. And with that, our 6-channel servo motor tester is complete. But there's one tiny thing left to do. I need some knobs for these spots. So let's head over to the 3D printer and print the knobs I just designed. Well, it turns out these potentiometers are a bit too stiff for our knobs to handle. But no worries, we have got our trusty screwdriver to do the job. So now it's testing time. I'm using my bench power supply to provide 6 volts to the circuit. Let's connect the servo motors now. Now I'm turning on the supply. It's working perfectly. Each servo is doing what it is supposed to do, as you can see here. The push buttons are responding well too, although they do miss a command every now and then, around once every 10 presses, but honestly, that's not a deal breaker for me. So guys, that's it. If you enjoyed this project, let me know your thoughts in the comments. For the program, circuit diagram and PCB design file, check out the link in the description. Thanks for watching.